Right, hear me out for a sec. What if I told you that every single time you flick on a light switch in your kitchen, photons from the future are already racing backwards through time to meet that bulb? Sounds like absolute rubbish, yeah? Like something a stoned uni student says at 2 a.m. But two of the sharpest minds in physics history, blokes who literally helped build the atomic bomb and rewrite quantum theory, sat down in the 1940s, did the maths, and came to a conclusion so wild that physicists today still argue about it over beers. Their names were John Wheeler and Richard Feynman, and what they cooked up is called the Wheeler-Feynman absorber theory. Stick with me, because by the end of this video, you will never look at a torch, a star, or even your own reflection the same way again. Because if these two were right, the future isn't just coming for you, it might already be here. Now, to get why this theory is such a massive deal, we've got to wind the clock back to Princeton University, 1940. Picture a young, cheeky genius named Richard Feynman, mid-20s, smart as a whip, and his mentor, John Wheeler, one of the most imaginative physicists who ever lived. They had a problem on their hands, a real headache. Classical physics said that when you wiggle an electron, it gives off electromagnetic radiation. Fair enough. But here's where things got dodgy. When physicists tried to calculate how that electron interacts with its own electric field, the maths exploded. Literally. The numbers ran off to infinity. And in physics, when your equation says infinity, it means you've stuffed something up. So Wheeler comes to Feynman one day and goes, what if the electron doesn't interact with itself at all? What if every charged particle in the universe only ever talks to other particles? And that's where the rabbit hole opens up. Because that single innocent question forces you into a corner so weird that the only way out is time travel. Here's the thing about Maxwell's equations, the laws that govern light and electricity. They've got two solutions. Two. Most teachers only ever show you one. The first is the retarded wave. Boring name, just means a wave that travels forward in time, the kind we're all familiar with. You drop a stone in a pond, ripples spread outward into the future. Easy. But there's a second solution baked right into the same equations, the advanced wave. And this one travels backwards in time. Imagine ripples in your pond converging inward, perfectly, and then disappearing into the spot where a stone is about to land. That's an advanced wave. For nearly 100 years, physicists looked at that second solution and went, nah, that's not physical, chuck it in the bin. But Wheeler and Feynman said, hold up, what if we don't throw it away? What if we use both? Now hang on a sec, because this is where most people's brains start leaking out their ears. Backwards in time? Photons that arrive before they leave? That sounds like Doctor Who fan fiction, not real physics. But here's the kicker. When Wheeler and Feynman crunched the numbers using both waves, every single problem with self-energy and infinities just vanished. Gone. The maths cleaned itself up like a guilty teenager before the parents come home. And the picture it painted was beautiful and bonkers. Here's how it works. An electron in your light bulb gets jiggled. It sends a wave forward in time, the normal kind. That wave races out across the universe at the speed of light, looking for somewhere to land. Eventually, it hits another electron, maybe in your eyeball, maybe in a wall, maybe in a star a billion light years away. That's the absorber. And the absorber, the moment it gets hit, sends a wave backwards in time, all the way back to the original electron, arriving at the exact instant the photon was first emitted. The two waves meet, they handshake, and it's that handshake, that conversation across time, that produces the radiation we actually observe. Let me give you a real-life example, because this gets abstract fast. You're in your backyard tonight, head tilted up, staring at a star 4 light years away. Standard physics says, yeah mate, that light left 4 years ago, travelled all that way, and just now smashed into your retina. Wheeler-Feynman says, nah, that's only half the story. The instant that star emitted that photon, your eye, 4 years in its future, was already responding. The deal was sealed instantly across space and time. The photon never travelled alone. It was always part of a transaction. Now I can hear you yelling at the screen. If the future is sending waves back to the past, why don't I feel it? Why can I remember yesterday but not tomorrow? Why does my coffee always go cold and never spontaneously heat itself back up? Brilliant question. And the answer is one of the most elegant ideas in modern physics. The advanced waves from the future do exist, but they almost perfectly cancel each other out. Imagine 1 million people whispering backwards through time at once. Most of those whispers interfere and silence each other. What's left is the faint impression of a one-way arrow, the illusion of time flowing forward. The arrow of time isn't a fundamental law, it's a statistical accident, a leftover. The universe started in a really low entropy state, super tidy, super organised, and ever since it's been getting messier. That mess is what we feel as the past. The future, by contrast, is silent, but it's still there, whispering. Okay, big twist incoming, because this isn't just some dusty 1940s curiosity collecting cobwebs in a textbook. This idea got dragged screaming into the modern era when a physicist named John Cramer came along in 1986 and said, what if Wheeler and Feynman were onto the actual nature of quantum reality? Cramer built what's called the transactional interpretation of quantum mechanics. And in his version, every quantum event, every electron jump, every photon emission, every measurement you've ever made is a handshake between the past and the future. The wave function isn't just a probability cloud, it's an offer. The future sends back a confirmation. And only then does reality lock in. Sounds mental, but here's the thing that'll really do your head in. There are experiments, real ones. Wheeler himself, before he carked it, proposed something called the delayed choice experiment. The idea was simple but devastating. You set up a quantum experiment where a photon has to choose between behaving like a wave or a particle. But you delay your decision about how to measure it until after the photon has already passed the decision point. Logically, the photon should have already made up its mind, right? Wrong. The photon's behavior in the past changes depending on the choice you make in the future. They've run this experiment multiple times, in labs, with lasers, and the result is the same every single time. The future appears to influence the past. Now, before you start packing a bag to go warn your younger self about that haircut from year 9, let's pump the brakes. This doesn't mean you can send messages backwards in time. The handshake only happens at the quantum level, and the cancellations smear out anything you might try to use as a signal. The universe, it turns out, is fiendishly good at hiding its own time-travelling postman. But here's the bit that will properly mess with your head. Wheeler and Feynman couldn't fully prove their theory was correct. But nobody, in 80 plus years, has been able to prove it wrong either. The maths still works. The infinities still vanish. And every new experiment in quantum optics keeps showing results that look suspiciously like waves that already know where they're headed before they leave. Modern quantum eraser experiments, weak measurement studies, even some interpretations of entanglement. They all whisper the same uncomfortable truth. Causality might not be a one-way street. The universe might be a conversation, not a monologue. Past and future talking to each other, every single moment, in every single atom. And every time you switch on a light tonight, somewhere in those photons, there's a tiny mathematical echo from a future that's already arrived. So mate, does the future change the past? Wheeler and Feynman would say it's not changing anything. The past and future were always one transaction, one moment, one impossible handshake stretched across the fabric of time. Look, if your brain's a bit cooked right now, do me a solid and smash that like button, because it tells the algorithm to push more mind-bending physics to curious legends like you. Hit subscribe so you don't miss the next one. We've got some absolute corkers coming up on quantum entanglement, the holographic principle, and whether reality is even real. And in the comments, I want to know, do you reckon the future can touch the past? Or is this all just clever maths dressed up as magic? Drop your take below. I read every comment. Catch you in the next one.